Hi, welcome back. So we are in chapter 4, inferential statistics, on the discussion of hypothesis testing. So we have done the introduction on the meaning of hypothesis. Also, we explore the number of factors that can define the right test. And eventually you reach out to introduce the following table. In this table, we brought most of the statistical tests that are available in order to give you a closer answer to the research question. Now, what we're going to do now, we will be looking at a number of questions. We read the question, we understand the problem, and we follow the logic to train ourselves how to choose the right test then. So this is the first question. It says that newborn babies are more likely to be boys than girls. Now, usually when you conduct the research, this is like, you could say, the statement of the problem, right? And a random sample, this is very important things to consider while reading. So it's a random sample that found that 13,173 boys were born among the total of 25,468 newborn children. The sample population of boys, according to this finding, it was like 51.72%, right? Is this sample evidence that the birth of boys is more common than the birth of girls? We know now always that the H0 or the null hypothesis is about equality, maybe with larger or less. And the alternative hypothesis is always about the non-equality, larger or maybe less. I can just easily say the null hypothesis, the proportion of boys equal to the proportion of girls. Now, the alternative says the proportion of boys is larger than the proportion of girls. Maybe we could say more officially that the proportion of boys is equal to 0.5. The alternative would be the proportion of boys is larger than 0.5. I got number of 25,468 subjects, right? I could have captured a variable, and this variable happens to be the gender. And at the end, what happened, I counted 13,173. Out of this number, which is 25,468, happens to be boys. This is a proportion of 51.72%. I would say it's more likely newborn babies are boys than girls, according to my finding from this sample. Now, this is my p hat. But in the larger population, the real p of boys in that population, because this is p hat from this sample. Now, to do that, I want to choose the test after I finish my research and I found my statistics, and this is my descriptive model. First of all, we need to ask how many samples we have. It's obvious we have only one sample, so I am in this side here. The next question is to ask what kind of variable, which is the x I am dealing with. It is a nominal because it's a gender, right? So it is a nominal. I am here now. So I should be somewhere in this square. And the available tests that you can use are here. The binomial test, test for proportions, one sample chi-square test. And after we do the test will spell out a value, right? Now, what will I do with this value? According to the level of confidence, I have a 0.05 then. Either the value happens to be less than this, or maybe larger than this. So if it happens to be less than the 0.5, then of course what would you do? You will reject the null hypothesis, which is this one, that the boys and the girls are equal. But if it happens that the value is larger than the 0.05, in this case, you will fail to reject the null hypothesis and say the boys and the girls have the same average born. Let's move to the next question. Researchers expect that the median number of reptiles would be 10. He measured the median for 12 subjects and recorded the median. 12 of these reptiles, and he decided to measure the length of that reptile. So, but what is the claim now? He says, well, he thinks that the median number of reptiles would be equal to 10. Null hypothesis says the median is equal to 10, and the alternative, the median, should be not equal to 10. Question is, after you finish, which test you should use to confirm the finding or the conclusion you've reached to? Once again, we ask how many sample we have? It's obvious we have only one sample of 12, right? I am here. The second thing is to ask what kind of variable outcome we are dealing with. It seems to be ordinal. So basically, with one sample on ordinal, I am in this block of cell. And obviously, I would be looking at the median. And that's exactly what we're looking at. So in this case, what test I would be using is one sample median test. Once again, once you reach, you will be spelling out a value. And then, of course, you will be comparing against the interested level of confidence, either to reject or to fail to reject. Next question. In this question, say we have a factory that produces beverage can, and the weight of this beverage can is 150 ml. Now, customer claims that the average of their product is less than 150 ml. And now researcher is hired to investigate. A batch of 300 cans were selected randomly and their weight were measured. So we have 300 cans, right? The variable X happens to be the weight, right? I would get, of course, obvious the X bar of them. We expect this to be 150. That we have the mu, or the, of course, the average mean, in this case for the weight, is equal to 150. This is what the claim of the company says, actually. But the alternative to say is less than 150. Question is, which test we should use? Obviously, we have only one sample. And I have a continuous type of a variable, which is in here. Now, the point that I'm trying to test, is it the mean against or the variance, since it's continuous, right? It's obviously the mean. And in this case, I will be using a t-test one sample. You will follow the procedures by testing either to reject or to fail to reject. Next question says that we have a company produce metal pipes of standard length. Now, 20 years ago, it tested production quality, and they found the length of the pipes they produce were normally distributed with standard deviation of 1.1 cm. The standard deviation, right, is derived from my variance, right? Now, they want to test whether they are still meeting this level of quality by testing a random sample of 30 pipes. I have like 30 pipes in this case, and the variable X happens to be the length. So here I have the S value from this sample. The null hypothesis says S is equal to 1.1 centimeters. And the alternative hypothesis, S is not equal to 1.1 centimeters. Obviously, we have only one sample, and we know since it is a continuous, either I am testing against the mean point or the variance. Obviously, it is the variance point, so I am here, and the right test to use is the chi-square for variance. Once again, you may test, and then the test will give you the value, and then you compare, and then you will get rejecting or failing to reject. Let's take one more question. 2 types of medication for hives are being tested to determine if there is a difference in the proportion of adult patient reaction. Now, 20 out of a random sample of 200 adults given medication A still had the hives 30 minutes after taking the medication. And there is a 12 out of another random sample of 200 adults given medication B still have hives 30 minutes after taking the medication. The first sample, 200 of them, I'm giving them medication A, and my variable X, by saying yes or no. The second sample, 200 people, the same variable were tested against the hive. I've got a proportion from here, the p hat of this first sample, to be 20 out of this 200 to have the hives after 30 minutes. Of another random sample of 200 adults given medication B, we've got 12 p hat 2 is equal to a 12 at 200. Obviously, after I finish by looking at these proportions, a medication B should be effective more than medication A. So obviously, the null hypothesis would be that the proportion of the people who still have the hives taking medication A is just equal to the proportion of the people who still have the hive taking medication B. And the alternative there is a difference. They are not equal proportions. First of all, how many samples we have? Obviously, we have 2 samples. They are independent because it's completely different a number of subjects. It is a variable to be a nominal one. I am in this region, and so I landed in the right test to say it's a z-test for independent proportions. So you get the value, and of course you will be testing that against the level of confidence you are interested in. In this question, say consider a phase 2 clinical trial designed to investigate the effectiveness of a new drug to reduce symptoms of asthma in children. Total of 10 participants are randomized to receive either the new drug or the placebo drug. Now, participants are asked to record the number of episodes of shortness of breath over 1 week period following receipt of the assigned treatments. Is there a difference in the number of episodes of shortness of breath over 1 week period in participants receiving the new drugs as compared to those receiving the placebo? I've got 5 of them and another 5 of them. So you get the first 5, they receive the new drug. Other group of children are receiving the placebo. Now, what is being recorded basically, the number of episodes of shortness of breath. This is my X, and this is to be the number of short of breath. And then you record the number here. So after I finish, basically what I would do, since these are a discrete number, maybe I will be calculating the median. So basically it's easy for me now to form my null hypothesis that median of A is just equal to the median of B. Alternative, that no, the median of A not equal to the median of B. In this case, the alternative suggesting that the new drug has an effect if this median is less. So we have 2 samples, and they are independent for sure. And then we are working against ordinal, and that's obviously I will be using this cell. So you got median test, you get Mann-Whitney U-test. This is the time maybe I would like to tell you distribution was the last factor to look at. Now, some of those tests, they consider the normality. It exists, so the variable is normally distributed. So you just need to make sure while you are doing univariate analysis to record whether your variable is normally distributed or not. So the next question, suppose we collect data for 600 people at our theater, all right? And for each person, we know the type of the movie they saw and whether or not they bought snacks or not, all right? Is some relationship between the movie type and the snack purchase exist or not? Well, this is quite interesting one. So I have 600 X1 to be the type of the movie, X2 whether they bought snakes or not. And I want to see a relationship between these variables exist or not, to capture from the sample whether the correlation exists between 2 categorical variables. Maybe you could have like 5 type of movies and then a snake's been purchased, yes and no. We calculate what we expect against the observed values, and finally we get the correlation. So in this case, how to form the null hypothesis here? They have no relationship. They are completely independent. X1 independent from X2, but the alternative says X1 and X2 are dependent. So which test to choose? First of all, you got 1 sample, but there are 2 variables. So in this case, we consider them under the category of 2 samples. And why there are 2? Because they are dependent. What kind of a variable that we have in this case? The nominal, obviously. And so I would be landing in this region here, right? Are you comparing or are you finding a relationship? Obviously, we were finding a relationship. So in this case, I will be using the chi-square test. Again, you do the calculation to find out this relation exists or not. The next question is a researcher wants to know whether or not 3 drugs have different effects on knee pain. So he recruits 30 individuals who all experience similar knee pain and randomly split them into 3 groups to receive either drug 1, 2, or 3. And then after 1 month of taking the drug, the researcher asked each individual to rate their knee pains on a scale from 1 to 100, with 100 indicating the most severe pain. So let's try to work out the null hypothesis in this case. The median of group 1 is equal to the median of group 2, median of group 3. And the alternative, obviously, that one of them should be not equal. Which test to use? We have 3, so there are more than 2, so we are in here. They are independent. Variable happens to be ordinal. So we are looking at the median, and the right test to use is the H-test, Kroskal, and Wells. So again, this test will spell out a value, and then we'll compare it against level of confidence, and either we reject or we fail to reject the null hypothesis. Let's look at the next question. A new fertilizer has been developed to increase the yield on crops, and the makers want to better understand which of the 3 blends of this fertilizer are most effective for wheat, corn, soybeans, and rice crops. They test each of the 3 blends on 1 sample of each of the 4 types of the crops. So we get blend 1, 2, 3. So we got 4 crops, C1, C3, and C4. Here is the yield, continuous value. So in this case, what is my null hypothesis? Mean of the first fertilizer is equal to the mean of 2 is equal to the mean of 3. And the alternative one, the mean of 1 isn't equal to the mean of 2 isn't equal to the mean of 3. First of all, to our question, there are more than 2 samples. They are completely independent, kind of a variable. The yield, it is a continuous, so I am somewhere here. It is of a mean, of course, so I will be here. Now the question is, you got one-way ANOVA, 1 factor, these are with 2 factors larger than 2 factors. We are testing 3 different groups of fertilizers. This is 1 factor. If it would have been, for example, the mean here, only we are doing the test like this, that would be one-way ANOVA, because you are basically testing the yield against 1 factor. Here we are adding a new factor, crops factor, and there is a fertilizer factor. So we are inside 2 factors, and in particular, we are interested either to use the ANOVA 2 ways without repeat of measures. Why without? Because it is an independent. Now, if the test was against the relation, then you will be working with ANCOVA. But here we are testing the mean. So let's look at the last question. There were quite a number of them, but I hope all of them are quite positively valuable to you. A survey among students of math department, history, and psychology to find out how many cups of coffee they drink per week. You want to know whether the variance of the individual subjects are the same. So you get S1 to maybe 10 students from the math departments, another 10 students from the history departments, and another 10 students from the psychology. And you're going to ask me how many cup of coffee they drink. X1 about the number of coffees. We will be calculating the sigma square. Forming the null hypothesis, obviously, the sigma square of the first group is equal to sigma square of the second equals sigma square of the third. Alternative that one of them at least is not equal, larger than 2, we are here, independent for sure, and we are looking at variance. So we are here. So the right test to go for is the pilot test or Levine test. So that was actually the end of inferential analysis. I hope now you have a strong foundation on starting your research from the very beginning to preparing your data as the first pillar, to extracting your descriptive model, the second pillar, and finally doing your inferential analysis by doing the test and getting your result that you find to be statistically significant or not. We are going to be next looking at our statistical software. See you then.